Welcome back to our printed circuit boards process series. Last time, we built a double-sided board with copper traces, laying down the basic skeleton of a PCB. Now it's time to laminate it into a multi-layer functional board. Today, we'll walk through the lamination process using a 6-layer PCB as an example. The lamination process involves several key steps: brown oxidation, stacking, alignment, pressing, and edge routing. First up, brown oxidation. Think of it as a surface makeover for copper. We start by soaking the copper in a 40 to 60 degrees Celsius alkaline cleaner for 1 to 3 minutes to remove any grease or residue. Next, we use a mix of sulfuric acid and hydrogen peroxide, or sodium persulfate with hydrochloric acid. Then, at 30 to 45 degrees Celsius, we lightly etch the copper surface for 1 to 2 minutes. This step roughens up the smooth copper, turning it into something that looks a bit like the surface of the moon, with tiny, evenly spaced bumps and dips. This gives the next layer more places to land. Next, we dip it into a brown oxide solution with organic acids, copper ions, surfactants, and stabilizers. At 50 to 65 degrees Celsius, the copper reacts with the solution for 2 to 5 minutes, forming a 1 to 3 micrometers hybrid organic-inorganic layer. This layer helps the next materials stick better, and it protects the copper from oxidation. After brown oxidation, it's time to stack the layers. Think of it like making a layered burger. Everything has its place. First, we insert 2 sheets of prepreg between 2 core boards. Prepreg is basically semi-cured fiberglass and epoxy. It's made by soaking fiberglass in epoxy resin. Sounds familiar? It's the semi-cured form of FR4, the material we mentioned in episode 1. It's firm enough to hold its shape, but still flexible enough to bond. Next, we add 2 more layers of PP film and a sheet of copper foil on the outside of the core boards. Now the whole stack looks like a PCB burger. The prepreg acts like glue, binding the cores and copper together. All set for the pressing step. And that's the basic form of a 6-layer board. So, here's a question. How do we count PCB layers? Easy, by the number of copper layers. Like this one, 2 copper layers on the outside, plus each double-sided inner board has 2 more. That's a total of 6 copper layers. Easy, right? Now the 6-layer stack goes into the lamination press. It goes through 3 key stages. Step 1, preheating. The press heats to 120 to 140 degrees Celsius, with vacuum below 1 bar. The resin inside the prepreg softens, and any moisture evaporates. The vacuum system pulls it all out, creating a clean environment for bonding. Next, main pressing. The heat ramps up to 180 to 200 degrees Celsius, and pressure is applied in steps. The resin melts completely and starts to flow, like molten lava. It fills tiny holes and gaps between the copper and layers, binding everything tightly together into one solid structure. Finally, curing. It's kept hot for 60 to 90 minutes, then cooled down slowly at less than or equal to 5 degrees Celsius per minute. During the whole process, the resin cross-links, like thousands of tiny hooks locking in place, forming a strong 3D network. This gives the board structural strength and prevents warping from internal stress. Once cooled, the board's still a bit rough around the edges, so it goes to the CNC router for trimming. The machine cuts it to the exact size and shape, removing the extra material. And we end up with a clean, functional 6-layer PCB with complex internal circuitry. And that's the full lamination process. We'll keep sharing deep dives into PCB manufacturing. If you enjoyed this, don't forget to like and follow. See you in the next episode.